So here's one more example of balancing chemical equations. This, as the title suggests, is one involving ionic compounds that have polyatomic ions. And one thing that's a little bit different about equations involving polyatomic ions is that many times the polyatomic ions remain intact. And so you can balance them as a unit. And a lot of people find that much faster and easier. But you can always balance by individual elements. So I'm going to show you how to do this one in terms of the polyatomic ions. So the question states, we're directed to write a balanced equation for the reaction between aqueous lead-2 nitrate and aqueous potassium chloride to form solid lead-2 chloride and aqueous potassium nitrate. So helpful to identify what the reactants are. And is plus. To form is where the arrow goes, and this other and is a plus. So we've got lead-2 nitrate plus potassium chloride, arrow, lead-2 chloride plus potassium nitrate. These are ionic compounds. We have to write the formulas. And to write the formulas, we need the ions. And so I'm going to have a little bit of scribbly work up at the top where I write my ion formulas. So what's the formula for lead-2 ion? Pb2 plus. Pb is the element symbol for lead. The Roman numeral 2 tells us what the charge is. How convenient is that? Nitrate. NO3 minus 1. That's one you just have to memorize. And then we've got potassium chloride. So what's the symbol for potassium ion? K plus. It's plus 1 because it's in group 1A. All group 1A metals form plus 1 ions. Chloride is just Cl, and position on the periodic table tells us the charge is minus 1. Then we've got lead-2 chloride. Oh, look, we already have the formulas for lead-2 and chloride. And the last one is potassium nitrate, and those are the other 2 ions. When we study types of chemical reactions, we will learn that what's happening here is that these ions are switching partners. Lead is coming in with nitrate, potassium is coming in with chloride. They're swapping partners, and potassium leaves with nitrate, and lead leaves with chloride. With our formulas for the ions and their charges, then we can write the formulas for the compounds. So lead-2 nitrate is going to be Pb NO3 2. There needs to be 2 nitrate ions because of the charge on the lead. What state symbol should I put for this? AQ, because the problem says it's aqueous. The next one, KCl, plus 1 charge, minus 1 charge. We don't need any crisscross or subscripts or anything. This is just KCl. And that one is also aqueous because the problem tells us it is. Solid lead-2 chloride. Looking at the charges on these, we need 2 chlorines, PbCl2. I'm not going to put parentheses around chlorine because it's just one atom and it's not confusing. And S for the state symbol. And then I've got KNO3. And as usual, I did not use my space wisely, and I'm running out of room at the end. KNO3, aqueous. Any questions? Very, very important first step, getting the correct formulas. Now we're going to balance this. I'm going to balance the polyatomic ion nitrate as a unit because I have nitrate as one of the ions in the reactants, and over here I still have nitrate. Sometimes you'll see it split up into nitrogen and oxygen, or nitrogen and nitrite, or something else. But this time they're the same. So I'm going to do my little tally method. I've got lead, I've got nitrate, I've got potassium, and I've got chlorine. In this compound, I have one lead atom, and I have 2 nitrate ions, and no potassium and no chlorine. And over here, I've got no lead, no nitrate, 1 potassium, 1 chlorine. Forgot to draw my line. Under PbCl2, I've got 1 lead, no nitrates, 2 chlorines. That's not the chlorine row. No potassium and 2 chlorines. And then over here, I've got no lead, 1 nitrate, 1 potassium, 0 chlorines. That make sense? So now that I took inventory, I'm going to look and see that I have 1 lead atom on the left side of the line of the arrow and 1 lead on the right side, so that's cool. And then I'm going to look at nitrate. I have 2 nitrate ions over here, none there, so a total of 2 on the left, only 1 on the right. How do I fix it? I need to put a 2 in front of KNO3. That changes all the numbers underneath. 0 times 2, well, that's still 0. But 2 times 1, that's going to be a 2, and this is going to be a 2. Now, my nitrate row, 2 on the left side, 2 on the right side. We're good. Then I look at potassium. On the left side, I have 1 potassium. On the right side, I have 2 now. So I need to put a 2 in front of KCl. I can't change the formulas. You can't decide that a bicycle has 5 tires just because it would be convenient for you. But you can have more bicycles. So that doubles all of those numbers. So that fixes potassium, 2 and 2. And then I look at chlorine, 2 and 2. And it's balanced. Not the only way to balance the equation, but this is the only correct answer for the balanced chemical equation. Any questions? This is something you need to practice and practice and practice and make mistakes and ask questions about your mistakes, and then it'll start to make sense.